mastering the reciprocal trigonometric functions: secant, cosecant, and cotangent. We will define and evaluate reciprocal trig functions, sketch and analyze their graphs and properties, and solve trigonometric equations involving reciprocals. Understanding these is a fundamental requirement for the Cambridge 9709 Pure Mathematics 2 and 3 syllabi. You will frequently encounter these functions in calculus when differentiating and integrating, as well as in complex trigonometric identities and equations. Mastery here ensures you don't lose straightforward marks in the early stages of a P3 exam. Let's start by defining the three reciprocal functions. You are already familiar with sine, cosine, and tangent. Their reciprocals are simply 1 divided by the original ratio. First, we have the secant of theta, abbreviated as SEC. It is the reciprocal of the cosine function. Next is the cosecant of theta, written as CSC, or sometimes COSEC. This is the reciprocal of the sine function. Finally, the cotangent of theta, or COT. This is the reciprocal of the tangent function. Since tangent is sine over cosine, cotangent can also be written as cosine theta divided by sine theta. Crucially, these functions are undefined whenever their denominators are 0. This is why we have these restrictions on the values of theta. Let's apply these definitions to evaluate the secant of 210 degrees. First, identify the quadrant. 210 degrees is between 180 and 270, so it lies in the third quadrant. Second, determine the sign. In the third quadrant, only tangent and cotangent are positive. Therefore, cosine is negative, which means its reciprocal, secant, must also be negative. Third, find the reference angle, alpha. For the third quadrant, alpha equals the angle minus 180. Now we calculate. Secant of 210 is negative secant of 30. Since secant is 1 over cosine, this is negative 1 divided by the cosine of 30. Recall that cosine of 30 is the square root of 3 over 2. Inverting the fraction gives us negative 2 over the square root of 3. To rationalize the denominator, we multiply by root 3 over root 3. Always provide the exact value in surd form unless the question asks for decimals. Understanding the visual behavior of these functions is key to solving inequalities and identifying domain restrictions. Let's look at the graphs of sine and its reciprocal, cosecant. Notice that wherever sine is 0, cosecant has a vertical asymptote. This happens at 0, pi, and 2 pi. The range is also distinctive. Since the maximum value of sine is 1, the minimum value of cosecant is 1. Similarly, where the minimum of sine is negative 1, the maximum of the local cosecant curve is negative 1. Now consider cosine and its reciprocal, secant. Secant follows a similar logic. It has vertical asymptotes wherever cosine is 0, such as pi over 2 and 3 pi over 2. Finally, let's look at cotangent. Unlike tangent, which passes through the origin, cotangent has an asymptote at x equals 0 because the sine of 0 is 0. It crosses the x-axis wherever cosine is 0. When solving equations with reciprocal functions, your first step should almost always be to rewrite the equation in terms of the primary functions, sine, cosine, or tangent. This allows you to use your calculator's inverse functions. Since cotangent is the reciprocal of tangent, we can write tangent of theta equals 1 over root 3. Next, we find the principal value by taking the inverse tangent of 1 over root 3. This gives us pi over 6. Now we must find all solutions within the given range of 0 to 2 pi. We use the cast diagram or the periodicity of the tangent function. Tangent is positive in the first quadrant, which gives us our principal value, pi over 6. It is also positive in the third quadrant. To find the third quadrant solution, we add pi to our principal value. So our two solutions are theta equals pi over 6 and 7 pi over 6. Always check your range at the start to see if the answer should be in degrees or radians. Here, the range was 0 to 2 pi, so radians were required. Let's solve a typical Cambridge-style question. This involves a trigonometric identity to convert everything into a single function. While we have not focused on identities yet, Recall from your previous studies that 1 plus tan squared equals SEC squared. This is a vital P3 tool. First, substitute the identity to get everything in terms of tangent. Now expand the brackets and rearrange the terms into a quadratic form. Let y equal tan theta to make the quadratic easier to see. Factorizing this quadratic, we look for factors of -6 that add to -5. Those are -6 and 1. This gives us two possibilities for tan theta. For tan theta equals -1/3, the principal value is arctan of -1/3, which is -18.4 degrees. This is outside our range of 0 to 180. Using the periodicity of tangent, we add 180. For tan theta equals 2, the principal value is arctan of 2. Both solutions are within our 0 to 180 degree range. In Cambridge examinations, students often lose marks on these specific points. First, confusing the reciprocal functions. A very common error is thinking that secant is the reciprocal of sine, because they both start with the letter es. Remember, the c goes with the c. Secant goes with cosine, and cosecant goes with sine. Second, neglecting the asymptotes when sketching. If a question asks for a sketch, you must clearly draw the vertical asymptotes as dashed lines and label them. Examiners look specifically for these to award marks for the shape of the graph. Third, giving answers in the wrong units. Check the range, degrees versus radians. If the range is given as 0 to 360, use degrees. If it is 0 to 2 pi, use radians. Mixing these up or leaving your calculator in the wrong mode is a guaranteed way to lose accuracy marks. Finally, overlooking the range of the functions, remember cosecant and secant never take values between -1 and 1. If you solve a quadratic and get secant theta equals 0.5, there are no solutions. Some students waste time trying to calculate an impossible value. When sitting your pure mathematics 1 or 3 paper, keep these examiner insights in mind to maximize your score. First, identify the method marks. In trigonometric questions, examiners often award a M mark for the correct substitution of an identity, or for correctly inverting a reciprocal function. Even if your final answer is wrong, showing the step where you turn secant into 1 over cosine secures that mark. Second, pay attention to exact value instructions. If a question uses the word exact, do not provide a decimal. Leave your answer in surds or fractions. Providing a decimal when an exact value is requested will result in the loss of the final accuracy mark. Third, always check for extra solutions. For tangent and cotangent, solutions repeat every 180 degrees or pi radians. For sine, cosine, secant, and cosecant, check the full 360-degree range. Use your cast diagram every single time to ensure you haven't missed a quadrant. Finally, rounding. Unless specified otherwise, Cambridge guidelines require angles in degrees to be given to 1 decimal place. Accuracy matters. It is time to test your understanding. Please pause the video and attempt these 3 questions. Easy. Find the exact value of cosecant of 3 pi over 4. Medium. Solve 2 cotangent theta equals -5 for theta between 0 and 2 pi. Give your answers to 2 decimal places. Hard. Sketch the graph of y equals 3 secant of x for the domain 0 to 2 pi. Label all intercepts and asymptotes. Take a moment to solve these before we move on to the solutions. Let us go through the solutions to see how you performed. For the easy question, we need the exact value of cosecant of 3 pi over 4. Cosecant of 3 pi over 4 is 1 over sine of 3 pi over 4. Since 3 pi over 4 is in the second quadrant, sine is positive. The reference angle is pi minus 3 pi over 4, which is pi over 4. This equals 1 over sine of pi over 4, which is 1 over square root of 2. This simplifies to the square root of 2. For the medium question, we solve 2 cot theta equals -5. Dividing by 2, we get cot theta equals -2.5. Rewrite this in terms of tangent. Tangent theta equals 1 over negative 2.5, which is negative 0.4. The principal value is arctan of negative 0.4, which is negative 0.38 radians. Since our range is 0 to 2 pi, we find the positive equivalence. Tangent is negative in the second and fourth quadrants. In the second quadrant, theta is negative 0.38 plus pi, which is 2.76. In the fourth quadrant, theta is negative 0.38 plus 2 pi, which is 5.90. The final answers are 2.76 and 5.90. For the hard question, we sketch y equals 3 secant x. This is a standard secant graph stretched vertically by a factor of 3. The bottoms of the upper curves are at 3, and the tops of the lower curves are at negative 3. Asymptotes are at x equals pi over 2 and x equals 3 pi over 2. There are no x-intercepts because the range is y is greater than or equal to 3 or y is less than or equal to negative 3. To summarize our lesson on reciprocal trigonometric functions, first, remember the definitions. Secant is 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tangent or cosine over sine. Use the SC rule to avoid mixing them up. Second, the graphs of secant and cosecant have a range where the absolute value of y is greater than or equal to 1. They also feature vertical asymptotes wherever their corresponding primary function is 0. Third, when solving equations, always convert the reciprocal function back to sine, cosine, or tangent first. This allows you to use standard inverse trigonometric methods and your calculator effectively. Finally, always be mindful of the required units and the specified interval in exam questions. Check your cast diagram for all possible solutions within that range.